Hey, OChemsters, this is Mrs. Manaway bringing another OChemster video. We are still in chapter 8, or excuse me, chapter 7, and we're in section 8, which is reactions involving alcohols dehydration. You've heard that before, haven't you? Before we get into it, but look at this. Maybe highlight this. Hey, yeah, let's go ahead and highlight this. What does it say? Here we go. For reactions involving most functional groups, remember, well, try it again. If you can make water, you will make water. All right. Um, we're going to see that over and over again. We're going to introduce that to you now with alcohols. So, ready? Let's do this. So, alcohols can be dehydrated. Well, what does dehydrate mean? Remember, we did dehydrogen halogenation. That was taking away a hydrogen and taking away a halogen. So, what do you think dehydrate means? Take away a hydrate. Well, what's another word for hydrate? It's water. So if you are dehydrated, it means you're thirsty, you need more water, right? So the dehydrated means you're going to take away water by what? Ooh, heating them. That's pretty important, isn't it? You've heard that before. By heating them with a strong acid. Hey, when did we see heat last? Oh, that's when we talked about E1 or E2, elimination reactions. What was elimination? Dehydrohalogenation. So let's check this out. What's an example? Ethanol. You know what ethanol is, right here. Okay, is heated. Okay, so it's over 50 degrees. Remember, we saw that was kind of like a magic number. So 180 degrees with a small amount of concentrated sulfuric acid. So that is my catalyst. So what do you think is going to happen? Well, I'm going to dehydrate it. It's going to E1. What must be a product if I have an elimination? It's an alkene. All right. I'm going to take away the water. And guess what I'm going to take away? An H plus. This H plus is part of the catalyst. All right. This H plus kind of belongs there. All right, so a catalyst is what is used up in a reaction and it's formed again so it can be reused again. Okay, let's continue. So my product, like I said before, is what? An alkene and water. All right, but the alkene, keep that in mind. Now this is a reverse of the hydration from chapter 2. All right, do you remember what chapter 2 was all about? It was all about alkenes. So if I start off with ethene, and remember what happens when I added water? Oh, by the way, I also need an acid catalyst, and there it is, all right? And what am I going to get? Well, do you remember what happened? Remember our my partially positive hydrogen here is going to go, oh, look at the electron buffet. It's going to be involved in breaking that bond, forming a momentary carbocation, which is positive, and then the OH is going to hop back on again, all right? So that was our addition reaction when I had my alkene. Do you remember that? Well, this is the exact opposite, isn't it? All right, so I can have my alkene, add water with an acid, and I'm going to make my alcohol. All right, so there you go, opposite from chapter 2. Let's go on. Well, let's talk about the mechanism then. Again, I know it's your favorite, not. All right, it's an elimination reaction, either E1 or E2. So what does it depend on? How do I know if it's E1 or E2? Well, first of all, I know I need heat. All right, that makes it an elimination. All right, but then what else does it need? Well, we remember how we determined if it's primary, it's always E2. If it's tertiary, it's always E1 or yeah, it's right, E1. So guess what? A tertiary alcohol, just like what we did before, will dehydrate by the E1 mechanism. All right, so let's check this out. So for a tertiary, the first step, a little bit different, is what? The protonation of the hydroxyl group. All right, so that's why I need this. So I'm going to protonate this. All right, and there I go. So what can happen now? Okay, what can happen now? This, remember in E1, when we had a halogen here, that was our first step. The bromine left first, okay? So now this protonated hydroxyl group, the whole thing is going to leave first. Let's check that out. All right, here we go. So the water is going to leave. Now that's a neutral water. Okay, what's going to happen next? If neutral water comes off, what am I left with? I'm left with a carbocation, aren't I? That should look familiar. So now what? All right, I'm going to take my carbocation, and this time I added all these hydrogens here. Why do you think I added all these hydrogens here? Because one of them is going to be my beta hydrogens. Does this sound familiar? And what's going to happen? It's going to leave, remember it was a dehydrohalogenation. Well, in this case, it's a dehydrohydrate, all right, hydration or something, all right? So I took away the water first, and now the H has to come off, and what am I left with? A double bond. That should seem familiar. So now what? It says the overall dehydration reaction is a sum of all three steps. Now there is something called Hess's law. Some of you may have heard that, other eye going, huh? And this is when I cancel out the same things and see what my overall reaction is. So your reaction, your mechanism, if you cancel out the like terms from one side's a reactant side, one side's a product side, we should be left with our original reaction. So isn't this the same as this? Yes, it is. Isn't this identical to this? Yes, it is. So what am I left with? My alcohol with an acid catalyst makes my alkene plus water plus my acid catalyst. Isn't that what, whoops, what I had before? And yes, it is. All right. So my overall reaction is this. And here I go. All right. So here's my overall reaction. It's like I said before. So here the H plus my catalyst, I'm creating new H plus. It's really the same thing, isn't it? Okay. Well, what do you think a primary alcohol is going to dehydrate by? If you said E2, you are correct. All right, what's going to happen here? All right, so here's my primary alcohol. See, there's only one carbon off of here. And here's my acid catalyst. All right, so what's going to happen is I'm going to make this. All right, and then what's going to happen? That, all right, is going to do what? Let me scroll down a little bit more. There we go. Okay, is going to create this plus my what? Plus my H plus, right? Yes, it is. Okay. And so how's that going to happen? This is going to leave, and then the H is going to come off of here, forming the double bond. Okay, so just like before. Okay, let's go on. All right, so the important thing to remember about the alcohol dehydration is that, first of all, they all begin by the protonation by adding the H plus to the OH group, the hydroxyl group. The ease of this alcohol dehydration is your tertiary alcohols are going to be a lot easier to do this than your primary. And guess why? All right, it's the same order as your cation stability. We learned about that back in chapter 2. We talked about Markovnikov's rule. All right, why do the hydrogens always end up with their buds? Well, Markovnikov recognized why, but recognized that it happens, but didn't know the why. The why is that the cation is more stable. So when we look at the stability of the primary versus the tertiary is a more stable cation. All right. Now it says sometimes a single alcohol can give two or more alkenes because the proton loss can come from any carbon that is directly attached. Okay. So typically it's from a secondary alcohol or possibly a tertiary if each of the carbon groups coming off of that central carbon is different. So maybe a methyl ethyl and a propyl group hanging off of that central carbon. Not very common, but it can happen. But if we have a secondary alcohol, yeah, it can happen. Okay, kind of like this. Okay, so here is my secondary alcohol. All right, notice I have an H either at the end or the H kind of in the middle. So I can get here or here plus your water, and then your H plus is your catalyst. Okay, so the alkene that is most substituted double bond will usually predominate, the one that has most things besides the hydrogens. This means that the alkene with the greatest number of alkyl groups on the double bonded carbon. So right here, I have one carbon group. I have this carbon group, all right? So it's kind of hanging out there in the middle, but this one is in the, or hanging out the end. This one's kind of in the middle, All right, so here I have, let's say, 3 carbons here and like 2. Yeah, it works out that this is your more substituted group. All right, and it's going to predominate. And so that's the one that's going to be your major product. Not saying you're not going to make any of this, but this one will be more common. This is just like what we did in the elimination from last chapter. Let's try the next one. Do me a favor, will you write out 3-methyl, 3-pentanol? Go ahead and draw that right now. Okay, this is what I came up with. And notice I have some of the hydrogens labeled. Why do you think that is? Well, it's going to make a difference on where the double bond is, all right? Why is it going to make a difference? Because this is a 2-carbon group. This is a singleton carbon group. Why didn't I care about this one? Because it's the same as this one. All right, so what could happen? If I use the green H, I would make this. If I use the red H, I would get that. So I have 2 possible structures in water. I'd also have that H plus, but that's my catalyst, okay? So go ahead and do letter B. Once you do the whole thing, go ahead and draw out 1-methyl cyclohexanol, and then try to come up with your different products. Take a little bit out and do that. All right, welcome back. Hopefully you paused it. All right. So this is what I got with a 1-methyl cyclohexanol. Notice I have a green H and a red H again. So here's one of my products. Oops, I left out my arrow. What happened to my arrow here? Where's my arrow? Here it is. All right, there it is. That's if I use the red H. What if I use the green H? All right, I could get that one. All right, and then don't forget you have water. So now what? It says in each case, which one do you expect will be predominant? All right, so let's find out. Here, let's go back up here again. So which one of these do you think is more likely to occur? The one that's hanging out and like in the middle, the double bond, or the double bond that's a little bit buried? Well, guess what? It's the double bond that's, oops, buried. Okay, right here. That one's going to predominate. So what about over here? Which one of these two do you think is going to predominate? The one where the double bonds is part of the hexene group, cyclohexene group, or the one with the double bonds hanging off of it? Well, if you said this one, you are right. Okay. All right, so that concludes section 7.8. Don't wait to be great. We'll see you next time. Bye-bye.